Probability page 14, number 5. The Venn diagram alongside illustrates the number of students in a particular class who study chemistry and history. Determine the number of students in the class who study both subjects, etc., etc. Here's something new. Instead of drawing like little dots or whatever for numbers or people, we're putting the total number of objects or people inside each of the regions. Okay, it's kind of an abbreviation. So let's see. Determine the number of students who are in the class. Okay, in a particular class who study chemistry and history. So let's say that this is math class or something. So in the math class we have all these people circled in red. How many total? Well, it will be 3 plus 5 plus 17 plus 4, which would be 29. How many of these people in this class? I guess maybe they mean like a grade, right? So maybe it's class of 2017 or something like that. Okay. So number of people in the class, or you, who study both subjects, chemistry and history. So that would be 5 plus 17 plus 4. In fact, it would be everybody except for these 3 people on the outside. It would be 26, right? It would be 29 minus 20, 29 minus 3, or it would be 5 plus 4 plus 17. What about the number of people who study at least one of the subjects? At least one of the subjects could be both, too, right? So, oh, I'm sorry, it's not 26 here. Number of people who study both subjects is the 17 people in the middle only, right? The 5 people here only study chemistry. I think when they say who studies both subjects, that means individuals who study both subjects, okay? All right. People who study at least one of the subjects. Now we put down 26, because that would be the 5 people that study chemistry only, the 17 people who study both, and the 4 people who study history only. What about the people who only study chemistry? That would be 5 people, right? That would be the 5 people here, and it wouldn't be these 17 people, because these 17 people study both history and chemistry. Okay, moving on. Number 7. For 2 events, A and B, we are given that number of people in the intersection between A and B is 5. Okay, that's written there. Number of people in A is 11. Now, what does that mean? Does that mean there's 11 here, or does that mean there's 11 in the whole circle? It means the 11 in the whole circle. So there's already 5 in the part that's intersecting with B. So what's the remaining number? It would be 6 who are in the bit apple part, and then 5 in the part that looks like a fish. So that would be a total of 11. Okay, what about the number of people in A union B? That would be 12. So that would be people in this region, people in this region, and this region, all added together would be 12. So let's estimate or calculate how many people are in B. It would be 1, right? Because 6 plus 5 plus 1 would be 12. Okay. Finally, the number of people in B complement, B prime, B dash, whatever, is 8. So the people outside of B are 8. And right now I can see there are 6 people outside of B. Where are the other 2 people? Oh, well, they're actually outside of B, and not only outside of B, they're outside of A, too. So this is the final picture of where people are within A, within B, and outside both A and B. Now, find the probability that that we have 2 events happening, or we have one or the other event, or both events happening. So it would be A union B, so that would be 6 plus 5 plus 1, which would be 12. It would be the same as the number of elements in A union B divided by the number of elements in U, which happens to be 6 plus 5 plus 1 plus 2, which is 14, right? So it would be 12 divided by 14, which could be reduced to 6/7 or whatever. Okay. Now, what's the probability that A does not happen, A complement? So there's a couple ways we could figure that out. We could figure out probability of A first. Probability of A would be the number of elements in A, which would be 6 plus 5, 11, divided by the total number of elements, 14. Okay, and then we could say, oh, well, the probability of A dashed, or not A happening, would be 1 minus 11/14, which we could write as 3/14. Okay? Another way you could figure that out is you could say, oh, where are the elements that are outside of A? There's a 1 there, there's a 2 there, 3/14. So there's two ways to figure that out. Number 9. 50 married men were asked whether they gave their wife flowers or chocolates for her last birthday. The results were 31 gave chocolates, 12 gave flowers, 5 gave both chocolate and flowers. If one of the married men was chosen at random, determine the probability that he gave his wife chocolate or flowers. How about if we draw a Venn diagram? So we're going to draw a Venn diagram called chocolate and a Venn diagram called flowers, and then the universal set there. And so chocolate or flowers, that would be like saying probability of chocolate or flowers. Chocolate but not flowers, so that would be the probability of chocolate and not flowers, right? Chocolate but not flowers. Chocolate but not flowers, okay? Neither chocolates nor flowers, so that would be probability of probability of neither chocolates nor flowers, so it would be everything outside of that, so it would be not chocolate intersected with not flowers. Okay, so let's fill in the sets here. 31 gave chocolates. 31 gave chocolates. So 31 gave chocolates. 12 gave flowers. 12 gave flowers. And 5 gave both. So we can fill this in with 5. And then 31 gave chocolates. So that would be, to put in this part, we would put 31 minus 5, which would be 26. Right? And then this part would be 12 minus 5, which would be 7. Okay? And there's 50 married men total, and what we have drawn so far is 26 plus 7, which is 33, plus 5, which is 38. There's 12 people out. Right? Alright. Okay, so what about the probability of C union F? C union F. So that would be 26, 5, and 7. Right? So that would be 26, 5, and 7 would be 38 divided by 50. Okay? What about B? Probability of chocolate but not flowers. Chocolate but not flowers. So chocolate but not flowers. Not flowers. Not flowers would be outside of the flower circle. So that's just the 26 people and that's it, right? And finally C, neither chocolates nor flowers. So that means it would be outside the C, and it also has to be outside of the F. So that leaves, let's do a different color. Neither chocolates nor flowers, that would be only these 12 people. The 26 people got chocolates, so they don't count. The 5 people got both chocolates and flowers, so they don't count. And the 7 people got flowers, so they don't count. So only these 12 people count. Okay? So that's the probability that the randomly chosen person gave neither chocolates nor flowers. Okay? Alright. And that's it for this page. So we'll make a new video next.